The scientific revolution began in the late 16th century, a period marked by a profound transformation in human thought and understanding. It marked a profound shift in human thought, moving away from traditional beliefs and towards a new way of thinking. The world was ready for a new understanding of the universe, one that would be based on observation, experimentation, and evidence. This revolution would change how we see our place in the cosmos, challenging long-held views and opening up new possibilities for exploration and discovery. Before this time, knowledge came mostly from religious teachings and ancient philosophers, who provided explanations based on tradition and authority. People believed that the Earth was the center of the universe, a view that was widely accepted and rarely questioned. This was the geocentric model, which placed Earth at the center of all celestial movements. But new observations and ideas challenged this view, leading to a paradigm shift in our understanding of the cosmos. The scientific revolution emphasized observation and experimentation, encouraging scientists to test their hypotheses and seek evidence. It sought to explain the natural world through reason and evidence, moving away from superstition and dogma. This new way of thinking led to groundbreaking discoveries and inventions, such as Newton's laws of motion and Kepler's laws of planetary motion. It laid the foundation for modern science, setting the stage for future advancements and the continued pursuit of knowledge. Nicholas Copernicus was a Polish astronomer. He challenged the long-held belief in a geocentric universe. In 1543, he published his revolutionary theory. He proposed that the Earth and other planets revolve around the Sun. This is the heliocentric model. Copernicus's theory was controversial. It contradicted the teachings of the Catholic Church. It also challenged the scientific establishment of the time. Many were resistant to accepting this new view of the cosmos. However, Copernicus's ideas sparked a revolution in astronomy. His work inspired other scientists to question the established order. It led to a new era of astronomical observation and discovery. Johannes Kepler, a German astronomer, built upon Copernicus's work. Kepler used meticulous observations of the planets. These were made by his mentor, Tycho Brahe. Kepler discovered that planets don't move in perfect circles. He found that their orbits are elliptical. Kepler formulated 3 laws of planetary motion. These laws accurately described the movements of the planets around the Sun. His work provided further evidence for the heliocentric model. Kepler's discoveries revolutionized our understanding of planetary motion. They helped to solidify the heliocentric model as the accepted view of the solar system. His work paved the way for Isaac Newton's law of universal gravitation. Galileo Galilei was an Italian astronomer and physicist. He made groundbreaking observations with the newly invented telescope. He observed the moon's craters, Jupiter's moons, and the phases of Venus. These discoveries provided further support for the heliocentric model. Galileo's observations challenged the authority of the Catholic Church. The Church still held onto the geocentric model. Galileo's work led to conflict with the Church. He was eventually placed under house arrest. Despite the challenges, Galileo's observations and writings helped to popularize the Copernican revolution. He is considered one of the founders of modern observational astronomy. His work demonstrated the power of the telescope as a tool for scientific discovery. Section 5. Unifying the cosmos. Isaac Newton, an English physicist and mathematician, revolutionized our understanding of gravity. He developed the law of universal gravitation. This law states that every object in the universe attracts every other object. Newton's law of gravitation explained why planets orbit the Sun. It also explained the tides and the motion of objects on Earth. His work unified celestial and terrestrial mechanics. Newton also made groundbreaking contributions to mathematics and optics. He developed calculus and the laws of motion. He is considered one of the most influential scientists of all time. Section 6. A framework for discovery. Francis Bacon and René Descartes were philosophers. They helped to develop the scientific method. This method emphasized observation, experimentation, and logical reasoning. It provided a systematic way to study the natural world. Bacon advocated for an inductive approach to science. This involves making observations and drawing generalizations from them. Descartes emphasized deductive reasoning. This involves starting with general principles and deducing specific conclusions. The scientific method revolutionized scientific inquiry. It led to a more rigorous and objective approach to understanding the natural world. it continues to be the foundation of scientific research today. Section 7. Unveiling nature's secrets. The scientific revolution was marked by the invention of new scientific instruments. The telescope allowed astronomers to observe the heavens in unprecedented detail. The microscope opened up the world of microorganisms. The barometer enabled scientists to study atmospheric pressure. These new instruments led to a wealth of new scientific discoveries. They expanded our understanding of the natural world in profound ways. They paved the way for further technological advancements. The development of new instruments and techniques continues to drive scientific progress. It allows us to probe the universe and explore the natural world with ever-increasing precision and detail. Section 8. A universe transformed. The scientific revolution had a profound impact on society. It was a period of great change, where new ideas and discoveries began to challenge the established norms and beliefs that had been held for centuries. It challenged traditional ways of thinking about the universe. For the first time, people began to question the nature of the cosmos and our place within it. The heliocentric model proposed by Copernicus, and later supported by Galileo, fundamentally altered our understanding of the solar system. This period of scientific inquiry led to the decline of religious authority in matters of science. The Church, which had long been the arbiter of knowledge, found its teachings increasingly questioned by new empirical evidence and rational thought. It fostered a more secular worldview. As people began to rely more on observation and reason, the influence of religious dogma in everyday life started to wane. This shift paved the way for a society that valued scientific inquiry and intellectual freedom. The scientific revolution also laid the foundation for the Enlightenment. Thinkers like Isaac Newton and René Descartes made groundbreaking contributions that not only advanced science but also inspired a new way of thinking about human potential and the natural world. This was an intellectual and cultural movement that emphasized reason and individual liberty. Salons and coffee houses became hubs of discussion and debate, where ideas about democracy, human rights, and the separation of church and state were fervently exchanged. The Enlightenment had a profound impact on politics, philosophy, and society. Philosophers like Voltaire, Rousseau, and John Locke argued for the principles of equality, freedom, and justice, which would later influence the democratic revolutions in America and France. The ideas of the scientific revolution continue to shape our world today. Modern science, with its emphasis on experimentation and evidence, owes much to the pioneers of this transformative period. They have led to countless scientific advancements and technological innovations. From the Industrial Revolution to the digital age, the spirit of inquiry and innovation that began in the 17th century has driven progress and improved the quality of life for millions. They have fostered a spirit of curiosity and a belief in the power of human reason. Today, scientists continue to push the boundaries of knowledge, exploring new frontiers in fields like genetics, artificial intelligence, and space exploration, all built on the foundations laid during the scientific revolution. Section 9. The Enduring Legacy. The scientific revolution was a pivotal period in human history. It was a time when the boundaries of knowledge were pushed and the very fabric of our understanding of the world was transformed. This era, spanning the 16th to the 18th centuries, saw the emergence of groundbreaking ideas and discoveries that would forever change the course of human thought. It transformed our understanding of the universe and our place in it. Before this period, the prevailing belief was that the Earth was the center of the universe, a view that had been held for centuries. However, through meticulous observation and innovative thinking, scientists like Copernicus, Galileo, and Kepler challenged this notion, presenting a heliocentric model where the Earth and other planets revolved around the Sun. It marked a shift from a geocentric to a heliocentric worldview. This was not just a change in astronomical models, it was a profound shift in how humanity perceived its place in the cosmos. The heliocentric model laid the groundwork for future astronomical discoveries and opened the door to a new era of scientific exploration. It established the scientific method as the foundation of scientific inquiry. The emphasis on observation, experimentation, and logical reasoning became the cornerstone of scientific progress. This methodical approach allowed scientists to systematically investigate natural phenomena, leading to a deeper and more accurate understanding of the world. The legacy of the scientific revolution lives on. Today, scientists continue to build upon the foundations laid during this transformative period. The principles of the scientific method are still at the heart of scientific research, guiding modern-day inquiries and discoveries. It continues to inspire scientists and thinkers today. The spirit of curiosity and the drive to understand the unknown that characterized the scientific revolution are still very much alive. This enduring legacy motivates new generations of scientists, researchers, and thinkers to push the boundaries of knowledge and explore new frontiers. Its emphasis on observation, experimentation, and logical reasoning remains the cornerstone of scientific progress. These principles have led to countless advancements in various fields, from medicine to physics, and continue to be the guiding light for scientific endeavors. The scientific revolution was not just about scientific discoveries. It was about a fundamental shift in human thought. It encouraged people to question established beliefs, to seek evidence, and to think critically about the world around them. It was about a fundamental shift in human thought. This intellectual movement laid the groundwork for the Enlightenment, a period that further emphasized reason, individualism, and skepticism of traditional authority. The ideas that emerged during the scientific revolution had a profound impact on philosophy, politics, and society as a whole. It was about our capacity to question, to explore, and to understand the universe around us. The enduring legacy of the scientific revolution is a testament to the power of human curiosity and the relentless pursuit of knowledge. It reminds us that through observation, experimentation, and critical thinking, we can continue to uncover the mysteries of the universe and expand the horizons of human understanding.